So chances are it's late in the night and you're watching this past paper video hoping that you get the answers to the past paper that you've been looking for all this time, and you're happy that it actually exists on YouTube. Well, don't leave it up to the YouTube algorithm to show you the rest of answers. I have an app that's called Learn It by makeITsimpleTT, and it has all the past paper answers in chronological order for the past 10 years, maybe 12, depending on the time that you're watching this video. It might have a lot more. The app is called Learn It. Go find it, download it. Link will be in the description. And if you want to see the PDF with the actual crap-o-foot handwriting that I have with the answers, so you could actually scroll through the PDF and look at the answers as it was written instead of watching the video, hey, you could do that too. Download the app now. Alright, back to the answers.
Alright, so we're on to section 2 now of section B, software engineering. Software engineering requires a lot of theoretical knowledge, plenty writing from time to time. So you want to make sure that your writing is on point and you understand how the marks are being allocated, because it's an exam. It's an exam you're doing, right? So explain what is meant by the term deliverable. A deliverable is like a deliverable is the expected output from a software project, a software system, once completed. It is usually expected by the customer as a functional requirement or non-functional, functional or non-functional requirement. Yeah, we'll just put that in functional, because this is why IA is functional or non-functional. Right. Yeah, basically. Alright, describe 2 main factors that must be considered during the feasibility study. Well, there are many different feasibility things, but usually your greatest reason for not being able to determine if a project is feasible is cost. For sure. Alright, now next one is technical feasibility, or the ability to do it, or so we say technical / operational cost. Alright, so cost. Can the does DOES, that's what I meant to say, does the system require too many right, does the system require too much financial resources that the customer cannot meet? Hey, what happened? Oh yeah, right. So yeah, so we'll go with that. Then we go with technical and operational. Technical and operational would be along the lines of does the technology exist to implement the solution? Technical operation. All right, so what others could you have? You could have cost, you could have technical, you have time. Do you have enough time to do it? Is it legal? The legality of it. Yeah. Alright, so I wouldn't put operational inside here because operational is something a little different. Operational is like having the time. Yeah. Operational is like having the framework in place for you to actually fill it out. Like if you want to build something that is on your web and on the and on desktop and on everywhere. Yeah. Right. Yeah, each one of those you can explain. Time is easy to explain. Legality, operational. They kind of common sense. They speak for themselves. Popular diet, drinking sold in many stores. Each store has one or more branches. A branch is supervised by a manager who hires employees. Oh, this is an ERD diagram. Yeah, it looks like an ERD diagram to me. Yep, draw an entity relationship diagram. Let's draw the entity relationship diagram. Drink is sold in many stores. So this is the drink The drink is sold in many stores. So we have drink, and then we have store. The relationship between these two is sold in, one drink is sold in many stores. Yeah, drink is sold by many stores. What's this said? A branch is supervised by a manager, or each store has one store has many branches. Has many branches. Right, but you can't put branches in plural because they wouldn't accept that. They used to have, you have to, like, usually would have like crow's feet, well, one or many. Alright, so that ERD diagram is sorted out there. So for accidentally press pause just now and answer this question, so you won't see me writing it down. So I'll just go through the answer because I don't know what happened to me. I was pressing pause. I pressed pause for something. Oh yeah, somebody sent me a message and I had to stop to answer the message. Anyhow, the answer here was the comparison between white box testing and black box testing. White box allows the tester to see and know the code that is being tested, which gives them the ability to pinpoint errors to be fixed, usually done by developers. The reason I have to put any usually done by developers because they put this for 4 marks. I can't say why this is 4 marks. So the only thing I can think of that will add to the 4 marks would be the people who do the testing. So done by developers. Black box doesn't reveal the internal workings of the code. It's usually done by alpha testers and beta testers to give feedback. That's what I think. But as a stretch for 4 marks, well, not stretch for 4 marks, but this question has been stretched to make it into a 4-mark question. Why? I don't know. State 2 advantages and 1 disadvantage of the evolutionary model to develop software. Evolutionary, what makes it better over time? Evolutionary is rapid prototyping. It usually, evolutionary is still on the syllabus. They have waterfall. Then we have rapid prototyping. Then we have reuse. And then we have, I'm not even sure if evolutionary is still on the syllabus. Hold on. Let me check this because I feel like I'm being hoodwinked here. SDLC. Okay, so that's this module here. Waterfall evolutionary development, including rapid prototyping. Oh, right. Okay. Yeah. So they have evolutionary, including rapid prototyping. Basically, I'll teach rapid prototyping because that's probably the one you wanted to do. But evolutionary is rapid prototyping is a type of evolutionary. So yeah, let's just get that clear, right? So the advantages of evolutionary approach. This 3 marks? Okay, it's 3 marks. So we're not gonna fight it. We're going to say that you get better over time. Gets better over time / revisions. That's 1. 2. I'll tell you, you get better user feedback. Honorable mention, we'll give honorable mention to prototypes or mockups are made available to the user. Yeah, that's usually a good one. Those 3 are usually good ones. Probably are about 5, but I'm not going to fight the 5. Those are the stronger ones. The biggest disadvantage is no clear endpoint. No clear end. You don't know when this thing gonna finish because you just keep adding on. And there's lack of structure development. Yeah. Alright, so they said evolutionary, but you probably want to just tell them what rapid prototyping is, essentially, for the most part. In a university registration system, this is the data flow diagram, 8 marks for the DFD. Let's get DFDing. This is usually the hardest question on the paper in my years of teaching. However, it's gotten a lot easier. Back in the day, you used to get a 14-mark data flow diagram question, 16 marks for a data flow diagram question, but now this one is 8. Not bad at all. Alright, so university registration system. Let's start off with getting our external entities. Student is definitely an external entity. A student sends an application form containing his or details and the course of which you'd like to register. The university checks the course file. So we're looking for the verbs here. Checks the course file. This is going to be check the course file. That is a process to find out whether the course is available. So the course file is definitely going to be what's called this thing by external entity, a file. Yeah. If the course file is available, the student is enrolled in the course. Maybe they're supposed to be enrolled in the course. Enrolled in the course as a verb. Enrolled in the course. So that is our process of enrolling in the course file, an update of the student file and the course file. The university confirms the enrollment. By sending a confirmation letter to the student. Sending a confirmation letter could be a next process, you know. I would say sending the let me do it and see. Because usually enrolling in the course might if you enroll in the course they will send an update one time. And I think that makes sense. Student sends application form. We'll just call this form. They send the form into a check of availability, check course or something. So we have it right here. Checks a course file. So check for course. Check availability. Where do you check for the availability? You check it from the course file. Where do we put the course file? We put it underneath here. We'll name it course file. The course file will send you the information about the course, the details, course details. Right. The university check if the course is available. If the course is available, the student is enrolled in the course. If the course is available, the student is enrolled in the course. Let's think about this. If the course is available, the student is enrolled in the course. Okay. So we'll put this. No. Right, yeah. Okay, so we'll say that if it's available, right, they'll send the details, the same application details, student info. Student info will go to our process. That will be called enroll student. That means they got in. In order to enroll the student, so if the course is available, the student is enrolled in the course via an update of the student file and the course file. So the enrolled student is going to update this file here with the student info. Yes, student info for the course. And then they also have to update another file called the student file. Update of the student file, which is up here in the course file, right? Yeah, so we'll say student file. So you got the student file. What information going to put in the student file? Student details again? Well, yeah, the student details going in both places. The student info will have to go in the course file that pertains to the course, and then the student details are going to the student file. I guess. Yeah. Right, so to enroll the student now, we have the university confirms the enrollment by sending a confirmation letter to the student. If the university confirms the enrollment by sending a confirmation letter, the student will send a rejection letter. If the course is unavailable, so if the course is unavailable, then I will send the rejection letter. And then if it is available, the enrollment by sending a confirmation. Okay, so if the enrolled student does all of this stuff, the enrollment student is going to be the one that has to send all of the information back this way. If only I could draw a straight line. Yep, that's as straight as it gets. Acceptance letter, confirmation details, acceptance letter. Yeah. Okay, let's every time we do a data flow diagram, check through your diagram to see if you covered everything that's in the paragraph, right? So let's see. In a university or registration system, a student sends an application form containing his or her personal details, right? Check the availability, right? The university checks our course file, so we check the course file to find out if the course is available. If the course is available, the student is enrolled in the course, so we send the student info to enroll in the course via an update of the student file. So it updates the student info, and it updates the thing. The university confirms the enrollment by sending a confirmation letter to the student if the course is unavailable. Yeah, I think that's it. You know how the acceptance letter going on. What information is going to be put in the acceptance letter? We didn't get anything, or we get the student info. We update information here. All right. So in order for the acceptance letter to actually have information that matters, we have to get course info. Yeah. Because for the acceptance letter to be sent, the acceptance letter must have the information about the course, which was in the course file. And yeah, the student info only got there. Right, yeah, that's correct. Yeah. So your name is 1.0 and name it at 2.0. Cool. It wasn't as easy as I thought it would be though. I thought it would be, it wasn't as hard as, it wasn't as easy. I thought it would be a little easier than this, but it was a little technical to go through the paragraph. Sometimes it might give it in point form, sometimes it might give it in, but this is basically it. So again, you have enough time in the exam. Go through the paragraph and make sure you read through what is taking place. Student sends in the application form. That's what they said. Personal details for the course. The only part in this question that's weird is that to send the acceptance letter, there is no stated input. So it says that the confirms the enrollment by sending a confirmation letter to the student. So this confirmation letter here, right, goes to the student. But in order for the confirmation letter to go there, the enrolled student process can't just take the student info that's coming in. The student info is not enough. You need to get the course info to be able to enroll the student. That's the only tricky part here that I would have probably missed if I did it without checking it over. Because they didn't say anything about the enrolled, and the information about the course is collected and then the acceptance letter is sent. They said if the student is the university confirmed the by sending a confirmation letter to the student. They didn't say by sending a confirmation letter with the course details. If they said that with the course details, then you would have known for sure you had to take the course details from here and put it inside it. But they didn't say that. And I believe that you have to assume that because by the laws of data flow diagrams, you can't create an output here without any inputs. And the only input that again inside here would be the student information. And there's no way you could create an acceptance letter without the student information and the course information. That's my argument, and I'm sticking to it. Yeah. That is the end of module 2.